Good day. In this video, we're going to teach you how to work with special angles. Special angles are 0 degrees, 90 degrees, and multiples of 90, as well as 30 degrees, 45 degrees, and 60 degrees. And all the information on this video is necessary if they ask you to calculate a trig sum using these angles and they say don't use a calculator. Let's start by drawing an equilateral triangle. So all the angles will be 60 degrees, each one, and let's say the length of each side is 2 units. If you then draw a line straight down the center here, perpendicular to the base, it will bisect the base. You'll have 1 unit here and 1 unit there, and those angles up there will be 30 degrees each. You can then work out the length of this side using Pythagoras. This 2 square minus the 1 square will give you AD square. Then AD will be the square root of 3. Then you have your one special triangle with all the sides worked out. Then you draw a isosceles right angle triangle and make this 1 unit and 1 unit. Use Pythagoras to work out the length of the hypotenuse. Then you'll see the length of the hypotenuse is square root of 2. From here, we're going to use these two triangles and the table I'm going to teach you now. At the end of the video, I will show you how we use the unit circle going through this table to get to this small table we're going to use to solve special angles using 0 degrees, 90 degrees, 180, 270, and 360. To find function values of 0 degrees, 90, 180, 270, or 360, firstly, 360 will have the same values as 0 degrees. Number 2, you can either learn this table, which is not that difficult, or use a calculator. We call it we cheat. Or we can use the unit circle, or you can use your graphs. What this table then says, sine of 0 degrees is 0, sine of 90 degrees is 1, sine of 180 is 0, and sine of 270 is minus 1, and sine of 360 is the same as the sine of 0. Please check cos yourself. Tan of 0 will be 0, tan of 90 degrees is undefined, tan of 180 is 0, and tan of 270 is undefined. Stop the video and make sure you have this table written down with all the information in it. Next, you know your 6 function names, sine theta and cosec theta that are friends, cos theta and sec theta, tan theta and cot theta. You know the abbreviation SOHCAHTOA. Sine is O over H, cos is A over H, and tan is O over A. O stands for opposite, A for adjacent, and H for hypotenuse. Cosec is the reciprocal of sine, sec the reciprocal of cos, and cot the reciprocal of tan, which means that if you have an O over H here, you'll have an H over O here. It flips over. If you have a right-angled triangle like here, and you stand in this angle, then this is my opposite, this is my adjacent, and this is my hypotenuse. If I stand in this corner, that is my opposite, that is my hypotenuse, and that is my adjacent. Now we're ready for our special angle problems. Firstly, we write down all the help we have. The heading of the following two sums says, solve the following without using a calculator. And they gave us sine squared 30 degrees plus sine squared 45 degrees plus sine squared 60 degrees. Firstly, put brackets for each of these 3 terms with the squares on the outside. Sine of 30 degrees is O over H from 30 degrees. Sine of 45 degrees is O over H standing at 45 degrees. And sine of 60 degrees is O over H standing at 60 degrees. Now going to my special triangles, sine of 30 degrees, I'm standing here. My opposite is 1 and my hypotenuse is 2. That I'll write here 1 over 2. Sine of 45 degrees is opposite over hypotenuse standing at 45 degrees. My opposite is 1. And my hypotenuse is square root of 2. Sine of 60 degrees, I'm going to stand at the 60 degrees. Sine is opposite over hypotenuse, which is square root of 3 over 2, which I can write in here. So this sum is now broken up into 3 parts. The pluses break it up. So we're going to do bed maths now. First do this exponent, then this one, then this one. 1 times 1 at the top gives me 1, and 2 times 2 at the bottom gives me 4, or a half times a half is a quarter. Next one, this 1 times 1 gives me 1. Square root of 2 times square root of 2 gives me 2. And the same on this one. Square root of 3 times square root of 3 gives me 3. And 2 times 2 gives me the 4. Now it's normal fractions plus and minus. Then you simplify, and you may stop at 3 over 2. Please stop the video and make sure you understand what happened here. Here is our last sum of this video. It says simplify without using a calculator. There are 4 terms here. The sum is broken up into 4 parts. Remember, plus and minuses breaks a sum up. I get my ratios from my 6 function names and their ratios. So sine is O over H, tan is O over A, sec is H over A, and cos is A over H. Remember to put all the special angles in brackets and everything else outside of those brackets. Because I know my special angles are fractions, I make everything else also into fractions. I made this a 2 over 1, and this a 3 over 1. Just to get my head ready for the fractions that are coming. This sum is quite a mouthful, so stop the video every few seconds. Now to find the answer of sine of 0 degrees, I go to my 0, 90, 180, 270 table. I see sine of 0 degrees is 0. Then you write 0 or 0 over 1. I'll show you just now where this came from. Then I go tan of 30 degrees. I go to 30 degrees. Tan is O over A, so it's opposite over adjacent. And then I fill into this bracket. Next we have sec of 45 degrees. We stand at 45 degrees. Sec is hypotenuse over adjacent. My hypotenuse is square root of 2. My adjacent is 1, which you fill in here. The next we have cos of 60 degrees. We can stand at 60 degrees. Cos, standing here, is adjacent over hypotenuse. So I write 1 over 2 in the bracket. Please stop the video and get your brain around this. Then we work out these 4 terms separately using bed maths. 2 times 0 is 0. You square this bracket, you times 1 is 1, and square root of 3 times square root of 3 is 3. Square root of 2 times square root of 2 is 2, and 1 times 1 is 1. You times the minus 3 with a plus 1 gives you a 3 at the top, and the 1 times 2 gives you a 2 at the bottom. Then you just plus and minus your fractions, and your final answer is 5 over 6. Please stop your video and get your head around this. For the purpose of this video, we are finished now. I'm just quickly going to explain where this table comes from. Just something interesting, if you get cos 0 degrees times tan 90 degrees, cos of 0 degrees is 1, but tan of 90 is undefined, doesn't exist. Then there is no real solution to this expression. If a piece of a sum is undefined, the whole expression is undefined. I told you in the beginning that this table that you're going to use comes from the unit circle. It'll go through here to get here now. This is only for those that really want to know more. It is to find the 0 degrees, the 90, the 180, 270, or 360. I told you you can use a calculator, the unit circle, or the graph, or this table. If you look at this unit circle, it means the radius is 1 unit long. Start by looking in this triangle. If you're standing here at 50 degrees, this is your opposite, this is your hypotenuse, and this is your adjacent. If you now take this hypotenuse, which is your radius, and you make it go lie down flat on the x-axis, you've got 0 degrees where the 50 degrees were. If you see that imaginary triangle there, your adjacent will be 1, that's your x value. Your opposite will be 0, there is no opposite. And your hypotenuse will still stay 1, or your radius will be 1. If you take this radius or hypotenuse, you move it up to 90 degrees, almost like this triangle. At the 90 degrees, my adjacent will be 0, my opposite will be 1, and my hypotenuse will still be 1. If you can't see this, just stop the video and ignore the rest. If you take this radius or hypotenuse right around 280 degrees, and you see that triangle over there, it's even flatter than that. Your adjacent will be -1, your opposite will be 0, and your hypotenuse will be 1 still. If you go all the way around to 270 degrees, your adjacent will be 0, your opposite will be -1, and your hypotenuse will be 1. And if you go all the way around back to here, you'll be back at your 0 degrees. The 360 is just on this line, and again my adjacent is 1, opposite is 0, and my hypotenuse is 1. Technically, I should have used the x, y's, and r's to explain these minuses, because an opposite is always a positive and adjacent is always a positive. But the position where it lies is negative, so don't break your neck around that. That's why I kept the x, y's, and r's with me all the time. Now I said at 0 degrees, my x value is 1, y is 0, and r is 1. The same way at 90 degrees, I filled in what my x, y, and r is. At 180, what they are. At 270 what they are, and 360 what they are. Then I said sine is y over r, and I filled it in here from my information. Did the same over here, here, and here. And eventually we got to all these numbers that we're using in our table. But now we just use this table and trust that all the numbers in here is right. Please indicate whether you liked or disliked the video and subscribe to the channel. If you run into a problem with special angles that you can't solve, you can send a clear WhatsApp picture of your problem to this number and a clear WhatsApp picture of where you tried it. Then we will try and help you and send back an answer to you as soon as possible. Enjoy special angles.